A decade ago, the announcement from Fuyan Cave in Daoxian province, southern China, landed like a tremor beneath the foundations of paleoanthropology. 47 human teeth, unmistakably modern in form, dated to more than 80,000 years ago, and possibly as old as 120,000. Even at that age, they posed a problem. This classification has not been challenged even by leading Western paleoanthropologists. These are dozens of modern human teeth. Fully modern Homo sapiens in southern China, tens of thousands of years before their widely accepted arrival in Europe around 45,000 years ago. The implication was uncomfortable but manageable for out of Africa. Perhaps there had been an early dispersal out of Africa that ultimately failed, a brave but doomed expansion that left no lasting genetic trace in living populations. But now the ground has shifted again. New uranium-series redating of the Daoxian material published in February 2026 pushes the age range dramatically deeper, into the window of 130,000 to 230,000 years ago. That is not a minor chronological adjustment. That is a tectonic one. It places anatomically modern humans in southern China before the last interglacial, at a time when traditional models insist our species was still confined to Africa, or only just beginning to expand tentatively into the Near East. The Daoxian teeth are no longer evidence of an early, failed migration. They are evidence of a long-established presence. And teeth do not lie. Unlike cranial vaults, which can shift shape under environmental, developmental, or even nutritional pressures, teeth are genetically conservative. They evolve slowly. Their cusps, roots, grooves, and enamel thickness encode deep ancestry. When paleoanthropologists compare fossil teeth, they are not looking at superficial resemblance. They are measuring cusp proportions, buccolingual and mesiodistal diameters, root morphology, basal lingual swellings, hypercone reduction, crown contour symmetry, and occlusal polygon patterns. Teeth preserve phylogenetic signal across tens or hundreds of thousands of years. If a dental sample falls squarely within the range of Homo sapiens and outside the Neanderthal or Erectus patterns, that assignment is not casual. In actuality, these dates align exactly with the split between African and non-Africans. Hidden inside genetic studies that purport to prove a late out-of-Africa migration is a fact that is never disclosed. While the model shows the so-called out-of-Africa migration occurred around 60,000 years ago, the actual split between non-Africans and African is dated to 130 to 230,000 years ago. This is a non-trivial fact that needs to be stated again. The out-of-Africa event is a bottleneck aligning to the Toba super-eruption 70,000 years ago, while the actual split is much, much older, between 130 and 230,000 years. Let that sink in. The Daoxian teeth were already described as fully modern in morphology. They do not show Neanderthal rhomboid molar contours. They lack the buccolingual elongation characteristic of many Asian Homo erectus populations. Their premolars and molars exhibit the reduced cusp complexity and slender root systems typical of modern humans. In fact, the original study noted that the sample appears more derived than some early modern humans elsewhere, resembling even middle to late Pleistocene humans and contemporary populations. That alone was striking at 80 to 120,000 years ago. At 130 to 230,000 years ago, it becomes revolutionary. Because at 130,000 years ago, we're in the last interglacial marine isotope stage 5e, when climates were warm and corridors between Africa and Eurasia were open. And at 230,000 years ago, we are approaching a period contemporaneous with early Homo sapiens in North Africa and possibly with Near Eastern occupations that have long been treated as failed dispersals. The National Geographic narrative has insisted on a sharp, late expansion out of Africa around 60,000 years ago, often linked to a single successful migration event that gave rise to all non-African populations. Earlier populations into the Near East have been relegated to evolutionary cul-de-sacs. Apidema and Mislaya in the Near East, dated to around 200,000 years ago, have been treated as anomalies. Modern human presence in China at 80,000 years ago was dismissed as another failed dispersal that left no descendants. But what happens when the teeth in China are older than the supposed African bottleneck? What happens when fully modern dental morphology appears in southern China 130,000 to 200,000 years ago? The failed migration hypothesis begins to collapse under its own weight. To argue that Daoxian represents a failed migration, one must assume that a population of fully modern humans travelled thousands of miles across ecological barriers, established themselves in southern China, persisted long enough to deposit dozens of teeth in a cave assemblage, and then vanished without contributing to later gene pools, only to be replaced tens of thousands of years later by a separate wave of modern humans from Africa, and that this second wave took essentially the same route, and that the earlier Near Eastern populations were also separate failed experiments. At some point, the number of failures becomes implausible. The Daoxian teeth instead suggest continuity. They suggest that Homo sapiens was not confined to a narrow African homeland awaiting a single launch moment, but was already dispersed across large portions of Africa and Western Eurasia well before 130,000 years ago, and capable of reaching deep into East Asia during favourable climatic windows. If modern humans were in southern China by 130,000 years ago, then the Near Eastern fossils around 120 to 100,000 years ago are not failed pioneers. They are nodes in a broader network. The problem is not the fossils. The problem is the model. These dates are even older than the much-hyped Hertoman from Ethiopia, which was supposed to be the nail in the coffin to any challenges to the out-of-Africa theory. Teeth do not evolve into modern Homo sapiens morphology overnight. The Daoxian dental pattern implies a lineage that had already undergone the anatomical transitions associated with our species. That transition began well before 200,000 years ago. If these teeth are indeed 200,000 years old or more, then the process that produced modern dental morphology must predate them. And importantly, dental continuity across sites tells a story of population stability, not ephemeral exploration. The Daoxian teeth cluster morphologically with later modern humans, not with transitional forms. That suggests a population already firmly within the Homo sapiens morphospace. The geographic implications are profound. Southern China is not adjacent to Africa. It is thousands of miles from the Near East and separated by diverse ecological zones. To reach Daoxian, Homo sapiens populations would have had to move across South Asia or along coastal corridors. This implies sustained dispersal capability and demographic viability. It suggests that by the last interglacial, modern humans were ecologically flexible and regionally established. Furthermore, the new dating pushes back against the assumption that East Asia was dominated exclusively by archaic populations such as Denisovans or late Homo erectus until 50,000 years ago. The Daoxian material indicates that fully modern humans coexisted with, or at least overlapped temporally with, these archaic groups far earlier than once believed. This reframes the genetic story as well. If modern humans were in East Asia by 130,000 years ago, then episodes of interbreeding with Denisovans or other archaic populations could have occurred much earlier and over longer periods than the simple 50,000 years ago, admixture pulse often proposed. Genetic introgression patterns that appear complex may reflect deep and repeated contacts across a wide geographic landscape rather than a single brief event. The Near Eastern fossils, long treated as isolated early attempts, now fit more naturally into a continuous belt of occupation stretching from North Africa through the eastern Mediterranean into South and East Asia. The Mediterranean corridor was not a gate that only opened once. It was a permeable zone of interaction across multiple climatic cycles. The Daoxian redating also forces reconsideration of European timelines. If modern humans were established in southern China by 130,000 years ago, why do they appear in Europe much later? The traditional explanation has been Neanderthal competition. But this assumes Europe was the inevitable next step in an outward march from Africa. A more nuanced interpretation is that early Homo sapiens populations occupied favourable ecological zones first, coastal and subtropical regions, and that colder glacial Europe was not immediately attractive or accessible. Europe may not represent the spearhead of expansion, but rather a later phase of regional integration. Furthermore, Neanderthal interbreeding around 200,000 years ago also proves that Homo sapiens were well established in Eurasia at this time. Importantly, the absence of early Homo sapiens fossils in certain regions does not necessarily imply absence of occupation. Preservation bias is powerful. Caves in limestone regions like southern China preserve teeth beautifully. Open-air sites in humid or dynamic environments may not. The fossil record is patchy, but when teeth are preserved, they carry strong taxonomic signals. And Daoxian is not alone. The notion of a single successful migration around 60,000 years ago was always an elegant simplification. It aligned neatly with certain genetic bottleneck interpretations and provided a clean narrative arc. But elegance is not evidence. As more fossils are redated and more morphological analyses are conducted, the story grows more complex and more ancient. The Daoxian teeth, now potentially 130 to 230,000 years old, suggest that Homo sapiens had already broken free of a narrow geographic confinement by the mid-Pleistocene. They suggest that modern morphology emerged within a widely distributed metapopulation spanning Africa and parts of Eurasia. They imply that dispersal was not a one-time event, but an ongoing process tied to climatic rhythms. And they challenge the idea that early Eurasian fossils represent evolutionary dead ends. If modern humans were in China 200,000 years ago and in the Near East 200,000 years ago, then these populations were not marginal anomalies. They were components of a larger demographic system. Some lineages may have contracted during glacial phases. Others may have persisted locally. Genetic bottlenecks visible today could reflect later climatic crises rather than initial dispersal. Teeth do not lie. They tell us that the Daoxian individuals were not transitional, not ambiguous, not archaic mosaics. They were Homo sapiens in the full anatomical sense, and they were present in southern China far earlier than the conventional narrative would comfortably allow. The implications ripple outward. Models of human evolution must account for early and sustained presence across multiple regions. The Near Eastern fossils can no longer be dismissed as failed experiments if contemporaneous or earlier populations were thriving thousands of kilometers away. The ecological and behavioral capacities of early Homo sapiens must be reconsidered. They were not lost explorers barely clinging to foreign landscapes. They were adaptable, mobile, and capable of establishing long-term occupations. The Daoxian redating does not erase Africa's role in human origins, but it strongly suggests that the emergence was followed quickly by dispersal and regional integration. The African homeland was not an isolated cradle sealed off for tens of thousands of years. It was part of a dynamic Afro-Eurasian continuum. In that continuum, the Mediterranean basin, the Arabian Peninsula, South Asia and East Asia were interconnected zones during favorable climatic windows. Populations moved, expanded, contracted, and interbred. Stone tool traditions such as the Aterian can be found across North Africa, the Middle East, and India before 115,000 years ago, proving that the migration of humans was primarily east and west, not south to north. The idea of a single dramatic exodus becomes increasingly untenable in light of mounting fossil evidence. Instead, we see a species already widespread by the last interglacial, navigating coastlines, river valleys, and forested landscapes from North Africa to southern China. We see dental continuity linking these populations to later humans. We see no clear sign of extinction between waves, only regional demographic shifts. The Daoxian teeth stand as small but powerful witnesses. Each crown and root preserves anatomical information that resists narrative simplification. Each cusp and groove anchors Homo sapiens firmly in southern China long before 60,000 years ago. Together, they undermine the idea that early dispersals were doomed. If anything, they suggest the opposite, that modern humans were already globally ambitious and regionally entrenched deep in the middle Pleistocene. The Near Eastern fossils were not a false start. Greece was not an anomaly. Southern China was not a late arrival. These were interconnected chapters of a long, complex expansion. And as more sites are redated, as more teeth are measured, the pattern will likely grow clearer. Human evolution was not a single-file march out of Africa at 60,000 years ago. It was a network of populations spreading, retreating, and reconnecting across continents for hundreds of thousands of years. The Daoxian teeth, now possibly 130 to 230,000 years old, demand that we accept that complexity. They remind us that the fossil record can overturn even the most entrenched models, and they prove once again that in paleoanthropology, sometimes the smallest bones tell the biggest stories. Thanks for watching.